Solidworks offers too many sketch tools to cover one by one in this introductory course. The good news is that most of them behave very similarly to the sketch tools we covered in the previous examples, so you'll easily be able to learn how to use them. However, there are some that are useful enough and different enough that I want to go over them here. The first one is the Sketch Fillet tool. When you have a sketch with a sharp corner, like with this rectangle here, you have a tool that will allow you to round the corner with an arc. This here is the tool, called the Sketch Fillet. You can see that the Sketch Fillet property manager has appeared. Here, you can enter the radius of the fillet you wish to create. I'll enter a value, and once that is set, I can hover my pointer over a corner, and a preview of an arc appears with the specified radius. You can also click on a line segment and hover your cursor over connecting or intersecting line segments to show a preview of the fillet. If the segments overlap, the portions you click on will be kept and the rest will be trimmed away. Once I click to add the fillet, notice that it is added to the Entities to Fillet section window. This box will populate with more fillets as they are selected. To remove a fillet from the list, I can either click on it in the graphics window, or I click on it in the property manager and press delete on my keyboard. To change the radius of the fillets, I can change the value in the spin box, or I can click and drag one of the yellow fillet previews in the graphics window. However, changing the size will affect all of the fillets in the Entities to Fillet selection window. There are two other options when creating sketch fillets: Keep Constrained Corners and Dimension Each Fillet. The Keep Corners Constrained checkbox ensures that any dimensions made to the corners before applying the sketch fillets will be maintained. I'll leave this option checked. The Dimension Each Fillet checkbox will automatically add a dimension to each of the fillets. This option makes all of the sketch fillets independent of each other, so if one of the values is changed later, the other fillets will remain unchanged. When this option is not selected, only one dimension will appear for all of the fillets, and equal geometric relationships will be created between the fillets, meaning that if I change the value of the dimension, the other fillets will also update to the size of the new dimension. I will leave the Dimension Each Fillet option unchecked. Before clicking the green check, notice that the Push Pin icon is selected at the top of the Property Manager. This option will keep the Fillet Property Manager open after clicking on the green check, which is useful if you want to create another fillet group with a different radius. I will click the green check to create the sketch fillets. One more detail about sketch fillets. If you create multiple sketch fillets with the same dimension all at once, notice that only the first one has a dimension on it. When you create a series of fillets, Solidworks will assume you want them to be the same, and it will automatically add an equal geometric relation. Now, if a change is made to this dimension, all of the fillets will change. What if you decide you need to make a change to just one of the fillets? Well, remember, there is an equal relation on these fillets, so you first have to get rid of the relations. As you saw earlier, to get rid of a geometric relation, simply click on the flag representing the relation and delete it. Now this arc is independent of the others. I can dimension it and give it a different value. Similar to the sketch fillet, a sketch chamfer allows you to break a sharp corner by adding a chamfer to adjacent sketch entities. To create a sketch chamfer, expand the fillet icon from the Command Manager and click Chamfer. The Property Manager is very simple. You have the option to create an angle distance chamfer, which uses a distance and an angle to define the chamfer, or a distance-distance chamfer, which uses two distance values instead. Regardless of which option you choose, the first parameter is applied to the first selection you make, which the second parameter is applied to the second. Let's take a look. I'll select angle distance and set the distance value to 20 millimeters and angle value to 60 degrees. I'll select the rightmost edge first and then the edge right below it. You can see the 20 millimeters was applied to the first edge I selected and the 60 degrees to the second. You can also select a vertex to apply a chamfer to. However, you don't have much control over what edge the parameter is applied to. If the chamfer doesn't look correct, simply click Undo in the Property Manager and make your selection again. The next option, Distance-Distance, lets you define two distance parameters instead. I'll set the first value to 10 millimeters, and the second one to 15 millimeters. I'll select two adjacent edges, and you can see the 10 millimeters was applied to the first edge I selected, and the 15 millimeters was applied to the second edge. As a quick side note, once you're done creating the chamfers, you can always edit the values by double-clicking the dimensions and updating the value. Another sketch tool we'll take a look at is the Offset Entities tool. Once you have some sketch geometry in place, you can use this tool to create a copy of that geometry that is offset by a given distance. When the Offset Entities tool is activated, you see the Property Manager change to show us some options. One of them is the offset distance. I'll type in a value and click the geometry I want to offset. You can either select all the geometry in the graphics area, or if the geometry forms a chain, you only need to ensure that the Select Chain is checked and select one segment. You will immediately see a preview of the offset geometry. If you want to change the direction of the offset, you check the reverse box here. If you want to create the offset in both directions, check the bidirectional box here. If you choose the bidirectional option, and the geometry is open-ended, you can use this option to cap the ends of the offset geometry with a line or an arc. You can also choose to convert part of the sketch to construction geometry. You can choose to convert the base entities, the offset entities, or both. In this example, I'll create the base as construction geometry. I'll click OK, and you can see that the offset is created. If you want to change the size of the offset, simply double-click the offset dimension and update the value. You can also change the direction of the offset here by clicking the reverse direction icon. Convert Entities lets you project existing geometry onto the sketch plane you're currently working in. In order to explain this more clearly, I've gotten ahead of the lesson just a little bit. What you see on the screen are two things. Here, I have this solid geometry called a boss extrude and a reference plane. You can also see that the block has a few holes in it. We'll take a look at how to create these in future lessons. For now, I'll only be using them to help me explain the Convert Entities sketch tool. The first thing I'll do is switch over to the Sketch tab of the Command Manager. Click the sketch icon, and select the plane in the graphics area to begin the sketch. First, what I'd like to do is create the same shape as the solid geometry's perimeter. A line, an arc, another line, and one last line to close the shape. As you've seen in previous lessons, I can use the Line tool and the Tangent Arc tool to create the shape one segment at a time. I could do it this way, but the Convert Entities tool is a much better way to accomplish this. I can click on the Convert Entities icon on the Sketch toolbar, or in the S key shortcut menu, without having the sketch or geometry pre-selected. This brings up the Convert Entities Property Manager. To capture the contour geometry of this tombstone shape, I'll simply select the edges of the geometry that I would like to convert. I can do this by individually selecting each edge. Notice that the edges I selected are added to the Entities to Convert selection window. To remove an entity, I can reselect it in the graphics window, or right-click on it in the selection window and select Delete. Or clear selections to clear the entire window. Another way to select the geometry is to right-click on an edge and choose Select Loop. Or I can simply select the face that contains the contour geometry. Not only is the geometry copied over, but notice that the sketch segments are all black or fully defined, although we didn't use any dimensions to constrain the sketch. The reason for this is that converted entities have a special geometric relationship called on-edge, meaning the geometry will change and update based on any changes that occur to the geometry it is based on. I'm going to skip ahead again for a minute to demonstrate a point. As I mentioned before, the on-edge relationship is special because it will change to always mimic the geometry that it is based on. So if I exit the sketch and change the shape of this tombstone, notice that the sketch changes and updates as well. This is a very powerful parametric capability of Solidworks that we will expand on in much greater detail later on in this course. Let's take a look at converting the holes into sketch geometry next. I'll edit the sketch I just created by clicking it in the graphics area. And from the context toolbar, selecting Edit Sketch. You can see I'm now editing the sketch again. I'll quickly delete the existing geometry and reactivate the Convert Entities command. As expected, you can click on each individual entity one by one. If I select a few holes and click the green check, you can see they were converted. Let me undo this. Alternatively, you can select the face and then use the Select All Inner Loops option to select all of the inner loops contained within the face. You can see that all 5 holes were added to the selection box, and when I click OK, the holes were converted into sketch geometry. In instances where you have complex sketches, like the one you see here, it's necessary to trim the sketched entities to get the final shape you're looking for. Solidworks offers a number of sketch trim options to help you do this. Let's start with this sketch here, and I'll activate my sketch trim tools by clicking the Trim Entities icon on the sketch toolbar, or with the S key menu. There are 5 trim options to select from. The power trim and trim to closest options provide the most powerful and most commonly used trim functions. The power trim option has a few different uses. For example, to trim this line back, or any other sketch entity, first select the sketch element to trim, and then with a second click, select the segment that it should be trimmed to. The power trim option also has the capability to extend sketch segments. I can select this sketch segment, and then move the cursor to the next sketch segment that I would like to extend to. It's also possible to use the click and drag method. Simply click the entity that you wish to trim or extend, without releasing your mouse button, and move your cursor to the entity it should be trimmed or extended to. One of the most powerful capabilities of the power trim option is to simply click and hold down the mouse button while dragging it around. Doing this will trim any sketch segments that are in the path of your cursor. The corner trim option allows you to select 2 sketch segments to trim away to create a corner, or extend 2 segments to create a corner. The trim away inside and trim away outside options allow you to define 2 sketch elements as boundaries, and any items inside or outside of the boundaries, respectively, will be trimmed. Finally, the trim to closest option allows you to hover your cursor over a sketch element, and the highlighted section will be trimmed away. It will automatically trim to the closest sketch segment. This tool can also be used to extend an entity by using the click and drag method explained earlier for the power trim tool. One lesser-known sketch option in Solidworks is Detach Segment on Drag. This setting, located in Tools, Sketch Settings drop-down menu, lets you detach a single sketch segment from the other entities. With the Detach Segment on Drag icon active, you can click and drag the sketch segment you want to detach from the rest of the sketch geometry to any location. You can always turn this setting back off by right-clicking anywhere in the graphics area and selecting Detach Segment on Drag. You can also unmerge a sketch entity at a single endpoint. To do this, enable Detach Segment on Drag either by going to the Tools, Sketch Settings drop-down menu, or by right-clicking on an entity and clicking Detach Segment on Drag. With the setting enabled, first click to select the sketch segment you want to detach. When I do, notice the endpoints change color. Then simply drag the endpoint you want to unmerge. The Segment tool allows you to add a specified number of equally spaced points or segments along a variety of sketched entities, including sketch lines, arcs, circles, splines, and parabolas. For this example, I'll sketch a center point arc. And I'll add 4 points along this arc. To do this, I'll go to the Tools drop-down menu, go to Sketch Tools, and select Segment. When I do, the Segment Property Manager appears. I'll go ahead and select the arc. You can see spheres appear along the arc indicating where the points will be created. I can adjust the number of points created by entering a value or using the arrows in the Number of Instances window. Below, you have the option to create sketch points or sketch segments. The Sketch Points option will create equally spaced points along the arc, whereas the Sketch Segments option will break the arc into individual segments of equal size. I want to create sketch points, so I'll select it and click the green check. You can see that the points are created coincident along the arc, and an equidistant sketch relation was added to each point. Notice when I drag the other endpoint, the points now remain equally spaced. You can modify the number of equidistant points by right-clicking on the equidistant relation and selecting Edit Segment Points. When I press the green check, the sketch entity updates to reflect the change. If I delete a point, again, the sketch updates automatically. Finally, if I delete the equidistant relation from one of the points, the equidistant relations is removed from all of the sketch points and replaced with coincident relations. Let me draw a circle next. If I use the Sketch Segments options instead, you can see Solidworks adds co-radial and equal length relations to each sketch segment. And if I resize the circle, the sketch relations are maintained. Similarly, if I use the Sketch Segments option on a line instead, I'll quickly sketch a line and activate the Segment tool. You can see Solidworks adds equal length and collinear relations instead. You also have the ability to apply the Segment tool to more advanced sketch entities, such as conics, parabolas, ellipses, and splines. However, these entities will be covered in the Advanced Parts course because they are beyond the scope of this lesson. Next, let's look at a tool that will save you time when creating symmetric sketches. When you're creating a sketch that is symmetric, you'll want to avoid sketching everything twice. What you do instead is create half of the sketch and then use the Mirror Entities tool to create the other half. For example, here I have some geometry already sketched. To mirror this geometry, I'll select the geometry I would like to mirror, and then I need to establish a line as a reference to mirror about. This line can be a center line or normal sketched line, which I can select by activating the Mirror About input box, and selecting the desired sketch line to mirror the sketch about. To keep the existing geometry that I selected to mirror, make sure the copy option is checked. Otherwise, the original sketch geometry will be deleted after being mirrored to the other side. The mirror tool actually adds a relation that keeps the sketch symmetric. If I drag a point on one side, the corresponding point across the center line changes as well. Also, if you have a shaded contour, there is an easier method than selecting each entity that makes up that sketch. You can simply click inside the shaded contour, then select the sketch line to mirror the sketch about. And you can see the entire contour was mirrored. If I click and drag, you can see the mirrored geometry updates as expected. You can also mirror sketch entities about planes or faces. I'll control-select both contours. And from the right-click menu, under Recent Commands, I'll select Mirror Entities. I'll enable the Mirror About selection box. And from the Flyout Feature Manager design tree, I'll select the top plane. I'll press D on the keyboard, click the green check, and the sketch entities are mirrored. Sometimes, you might find yourself in a situation where you need to repeat the same sketch geometry over and over. Solidworks has tools called sketch patterns that let you do this really quickly. You can create a linear sketch pattern to copy sketch geometry along two axes, or a circular sketch pattern to copy geometry in a circular fashion. Let's go over a quick example of both. I'll start by sketching a small circle on the origin. With the circle selected, I'll click the Linear Sketch Pattern tool on the Sketch toolbar. Before I go over the other options here, let me go down to the bottom of the Property Manager. This is the Entities to Pattern selection box. Here is where you specify which sketch entities you'd like to pattern. Since I had the circle pre-selected, you can see SolidWorks automatically added it to the selection box. But keep in mind, you can choose as many entities as you want. You can see by default, the X-axis and Y-axis are selected for the pattern direction selections. If you want, you can choose a different line or edge to define the pattern direction, but I'll leave the defaults. Under Direction 1, you can see we have options for the spacing distance, as well as the number of instances. I'll increase the number of instances and adjust the spacing to spread them out a bit. The checkboxes here give me the option to add a spacing dimension and instance count to the pattern to the graphics area. I almost always recommend checking them both. This way, you can edit the pattern right from the sketch later on. Finally, at the bottom, I can add an angle offset to rotate the pattern axis. I'll leave this set to 0. We have the same options for Direction 2. Notice, as soon as I increase the number of instances to 2, the rest of the options become active. I'll change the spacing dimension to spread the entities out a bit. You also have the option to dimension the angle between the pattern axis. Again, if you're creating a two-direction pattern, I recommend checking these boxes as well so you can adjust it right from the sketch. At the very bottom of the Property Manager is the Instances to Skip selection box. With this selection box active, just click the dots in the graphics area corresponding to the instance you would like to skip. If you change your mind, you can click it to bring it back. I'll clear Direction 2 and click the green check to accept the pattern. Notice the spacing and instance dimensions were added, and you can edit them right from within the sketch. Next, let's take a look at circular sketch patterns. Just as before, the first thing I'll do here is select the entities to pattern. I'll choose the circles we just patterned. Notice that if I try to group select all the circles using a selection box, nothing happens. You have to individually select each entity when using the mirror sketch pattern. Next, you can select the center of a pattern. Notice that SolidWorks automatically sets this to the sketch origin, 0, 0, but you can change the location by using the X and Y spin boxes, or selecting your own point. And change the spacing between the pattern instances. I'll set the point to 1 in the X direction, and 7 in the Y direction, and leave the spacing to 360 degrees. Just like a linear pattern, you can set the number of instances in the spin box here, and space them equally by checking the Equal Spacing checkbox. add dimensions to the pattern, and skip instances. As a quick side note, you can also adjust the pattern by specifying the radius and arc angles instead by using these two spin boxes. But I'll leave them as is, and press the D key to access the green check to finish the pattern. You can see how using patterns is a quick way to replicate sketch geometry, and is a big time saver versus sketching each one of these instances individually. Up to this point, all the sketches we have looked at have been on a reference plane. One thing I want to show you is that you are not confined to sketching just on reference planes. I'm going to be getting ahead of the curriculum just a second to show you what I mean. I'll start a new sketch, just like we've done up to this point. I'll select a sketch-based feature, a boss extrude, and create a simple rectangular sketch. The next step to complete the feature is to simply exit the sketch. I'll click OK to create the feature. Don't worry, we'll go into much greater detail about these commands in the upcoming lessons. At this point, if I have a need to create a sketch on this face, I can do so without having to create a plane or picking one of the default reference planes. I can simply select the faces as my sketch plane. Now I can create any sketch geometry I need on this face. Something else to keep in mind. You don't actually have to sketch on the face itself. I can sketch anywhere in space. And as you can see, I'm really still sketching on the same face. Think of the face as being an infinite plane, so that no matter where I sketch, the sketch geometry will always be at the same level as the face I selected. I point this out because many users experienced with more primitive CAD systems are quick to create planes when they're really not necessary. As you've seen in previous lessons, the typical workflow for creating a sketch is to enter sketch mode, select a sketch plane, and then begin sketching. To create a new sketch, you would have to exit sketch mode, enter sketch mode again, and then repeat the steps. While this process isn't too bad when you want to create just a few sketches, it can be inefficient when you need to create a larger number of sketches. For those cases, Rapid Sketch lets you create sketches without having to go through all of these steps, so it can be a great time saver when you have to create many sketches. You can find Rapid Sketch on the Sketch toolbar, or if you don't see it, you can add it by going to the Options drop-down menu, Customize, Commands, and Sketch menu. I'll click the icon to enter Rapid Sketch mode. Then I'll click on the Circle command and sketch a circle on my face. If I move my cursor over another face, I can simply sketch a circle on that face, and a new sketch will be created. You'll notice that I didn't have to choose any sketch planes or enter or exit any sketches here to create these sketches. So you can immediately see how Rapid Sketch can save you time. I'll continue creating sketches on any available faces, but once I've started a new sketch, I won't be able to go back and edit any previous sketches until I exit sketch mode. Once I exit sketch mode, you'll notice that each of the sketches appear in the Feature Manager design tree, and I can edit the sketches or use them for sketched features, just like with any other sketch. The Sketch Text tool in Solidworks makes it really simple to create a sketch from the text you type and later use that sketch to edit your part models. I'll open it from Tools, Sketch Entities, and Text, and select a face for the sketch. In the text box, any text that you type will be turned into a sketch curve, as you can see in the graphics area. One way to manually position the text is to simply click somewhere, and the text will be moved to the cursor. To get more accuracy, however, I would recommend using some kind of reference geometry, such as a center line that you can add into your sketch. Or you can use the edge of a model to place the text. For this example, I'll select this edge of the model to locate the text. Here, I can set how I want the text to be positioned in relation to the reference edge I selected, such as the alignment, or I can flip the text. If I don't want to use the default font defined for the part file, I can uncheck Use Document Font box and adjust the size, spacing, or choose a different font. I can then create an extrude or a cut extrude to give the text some depth.